All right, Chapter 6, Day 3. Chapter 6, Day 3, Transforming Data. We have talked about transforming data, but it's been quite a while ago. So let's say I have a normal curve and the mean is 5. And I take this data set and I add 5 to every number in the data set. What changes and what doesn't change is what we want to look at today when we're transforming data. And again, we've talked about this. It's been a little while. If I add 5 to this, to every number in the data set, what's going to happen to this curve? Is it going to change the shape of the curve at all? No, no. The shape will be unchanged. Is it gonna make the curve wider or narrower? No. The spread will be the same too. So what is the spread that we usually deal with? That's the shape. What spread do we normally run across in this class? Standard deviation. Standard deviation. Yep. So your Sx or your sigma, sigma x, anything like that, that's going to be unchanged. Whether your shape is normal or skewed right, skewed left, it doesn't matter. What about the mean? Oops. Yes. What's that? The mean is going to change, right? The mean will change. What else would change? The median would change, right? Good. How about Q1 and Q3? Would those change? Yes. How about the minimum and the maximum? Yeah, they would all change by 5, right? If we're adding 5, everything's going to get changed by 5. But the shape and the spread are not going to change. So when we add or subtract a constant, to a data set, the shape and spread are unchanged while the mean, median, Q1, Q3, minimum, maximum are all changed. Well, I can't spell while today at all. They're changed by exactly that constant. So as I recall, when we did this a while ago, I think this was way back in September, we actually plotted out a graph, and then we added a bunch of numbers in like our L1, and then we looked at it again and saw that it didn't change anything. I forget exactly when those notes occurred, but how about same idea, same curve, 5 for the median. How about if I multiply 5 to every number in the data set? How is multiplying by 5 going to change it? Is it going to, when you say change the shape, do you mean like from skew right to normal or something like that? It's going to change the spread. That's true. So if you're multiplying by a number smaller than 1, it's going to shrink it. If you multiply by a number bigger than 1, it's going to expand it. But what about the height? The height should also change, but the shape? The overall shape should be unchanged. Yeah, it's actually not going to change the shape. But the spread and mean, median, mode, all that, or not mode, but mean, median. So there's lots of things for spread. Variability is kind of another term for a generic term for it. That's going to be your standard deviation, your interquartile range, your range. Those are all going to change. And mean, median, Q1, Q3, min and max. Will be changed. So really it's the spread. If you add or subtract, the spread is unchanged. If you multiply, the spread is changed. Otherwise, the shape stays the same, and your measures of central tendency will be changed on both of them. So the difference is the spread is where the difference is on these two. Okay. So far so good? Everybody with me? All right. So let's look at the mean. How do we do that one? The other term that I want you to be looking for, to be thinking about mean at this point, oops, my pencil has died, is expected value. This book is using the words expected value an awful lot. What they mean is mean. What's your average? And I gave you a new symbol for this the other day. For expected value, the E. Yeah, good. The expected value of a sum or difference of random variables we'll call it excuse me, mu of s for mu of sum. Hey, I set you up close so that I could, yeah, spray you. Keep it up, you will be. Is mu of x plus or minus mu of y, or y, sorry, just y, equals the mu of x plus or minus the mu of y. So if you want the sum, or technically the difference, all you have to do is add or subtract the means, your mean values. So if you're looking for this sum, it's easy for when we're dealing with means. Standard deviation, not so much. Let's see. Standard deviation, sum or difference. Of random variables. This cannot be done directly. And this is one of those little key points in stats that would be the difference of getting, a couple more points on the AP exam. Okay, this is one of those ones that they kind of look for that I think a lot of people forget. But we can add or subtract the variances. Now, variance is something that's important, but not something we run across all that much. When we're finding standard deviation, it's actually the square root of variance is what standard deviation is. So sigma equals the square root of variance. So if we pulled up the formula, which I think we wrote down once, we'd look and see that there's a square root in standard, or getting the standard deviation. So how can I turn a standard deviation into a variance? Square it, yeah, square it. Right, if I square the standard deviation, I get the variance. So here's a quick example. Let's say we want to find the sum of sigma x 1.2 and sigma y if I want to find the sum of that, I've got to take these back to the variance form. So I'm going to take 1.2 and I'm going to square that. Then I can add it to the 3.4 if I square it, which is going to give me my variance values, 1.44 and 11.56. These would be the variance values, and I can add them, which is going to be 13. But how do I take it back to a standard deviation then? Take the square root. Right, take the square root of the sum of the variances. Which gives us the correct answer for the sum of the standard deviations. Clearly it's different than adding 1.2 and 3.4. That just doesn't work. You just don't. It just doesn't work. So change to variance. sigma squared s equals sigma squared x plus or minus y equals sigma squared x plus or minus sigma squared y. And then we have to change it back to standard deviation by taking the square root of that answer. I think I've written that wrong. Actually, now that I look at that, that should be variance and not sigma. But yeah, I think we need to change this to variance. Let's just use a capital V for that. Sorry about that.